This video is prepared for the course of Learning Analytics offered in the Learning Technologies program at the University of Minnesota. I'm the instructor Bodong Chen. This video focuses on data wrangling in the context of Learning Analytics and introduced a tool called Data Science Studio, which is really user-friendly tool for data wrangling. And for last night's class, we got a lot of chance to explore or share our experience in data wrangling. However, we didn't get a chance to have our hands dirty on a specific tool to experience the process of data wrangling using the tool. So I decided to produce this demo so that you can review the demo and then choose to explore this tool and potentially discover some useful functionality for your own research project. Really briefly, the tool is called Data Science Studio. It is a software platform that aggregates all kinds of functionality for data-intensive projects. So the tool can support the process of turning raw data to production-ready applications. However, in this demo, we're going to only focus on turning raw data into something that becomes analyzable for a specific project. And to begin with, I want to highlight a few critical concepts in DSS. And first of all is a data set. And maybe I don't need to explain it anymore. So it's typically, you can imagine a data set in Excel in a tabular format, or a data set in a MySQL database, or in some other cases, data sets in non-relational database, for example, MongoDB. They can all be handled by DSS. So when you get a data set, the next step is to process the data. So in DSS, there is a concept called script, which kind of record all the process you go through when you're cleaning the data using DSS system. However, the scripts here are quite different from the scripts, for example, in programming language Python or R, because in those different environments, you, as a data wrangler, you need to write this code by hand. However, in DSS, it's quite different. The difference is you will go through the data cleaning process by using a user interface, which can be similar as Excel or SPSS. But what's the difference between DSS and Excel is that all the process are recorded as scripts. So it makes the process reproducible, and you can choose to edit the script and if you find there's an issue with the script. So this is tied to the notion of reproducibility, which is really critical in any data analytics project. So imagine you have already produced a script, process a data set to another format that you're happy with. So you can choose to produce or save it as a recipe. So when there are new data coming into the system, and then you can just rerun the recipe to produce a new data set. And you can produce a range of recipes for different purposes, from data cleaning, data preparation, to specific kind of analysis you want to do. So this is also like highlighting one key thing or key concept in data analytics project, which is rerun and update data and reproduce the results just by clicking the button, which is really powerful, I think. So going even one level up, so in DSS there is a concept called flow, which basically give you a visual representation of the whole process of data processing in DSS. Imagine you first get a raw data set and then produce a recipe to clean the data, and then use the clean the data to do some analysis. So those steps will be visualized in the chart, and DSS call that the flow or flow chart, however you want to call it. So you'll get a better understanding later when you go through the demo, but I just want to highlight those critical concepts in DSS. So to begin with, first download DSS and install that on your computer. So there are two options. The first is to download the community edition and install that. It is free. Install that on your own computer. The second is to register for a free trial on its website, and I choose to download it and install on my computer, and I find the process pretty easy and straightforward to do. So for this demo, we are going to use some openly available dataset from the Ontario context. And specifically, the dataset we're going to focus on is from the Toronto District School Board, which is called Learning Opportunity Index. And for this index, it ranks every school based on measures of external challenges affecting student access. So you can just imagine it's a score that assesses how the school is supporting its student to succeed. And for the school, for the school which are facing greater challenge, it will have a greater number, and you'll be ranked higher in the LOI index. So, and also TDSB will update this index every 2 years. So when we have the data set, we want to ask some simple questions just for the demonstration purposes. So for example, are schools progressing over the years? Do schools of different kinds, for example, English school or French school, elementary school or secondary school, or bigger school, smaller school, or schools from different areas or regions, do they progress differently? So we can ask this kind of simple questions. And to answer those questions, we need to clean the data, because the data, as you see from this slide, are coming from a variety of different sources. So we need to clean the data, then we need to link the data, because one data set cannot answer these questions. So these are the typical challenges you'll face when you're doing data wrangling in any kind of project. So a basic overview of the data set that can be accessed freely, openly online. The first one is the LOI data, which is in the PDF form, PDF document published by TDSB. So in this data set, it has school name, the word number, the LOI score, and ranks from 3 different years. And it basically have the information we want about LOI. However, it doesn't have the information about school level, school language, or school location, or school enrollment we want to have to answer these questions. So there are 3 other documents or data set that contain that information, including the Ontario Public School Contact Information, Ontario Public Schools Enrollment. Both of them are openly available in the government open data catalog. And the other information, which is a postcode, can be found on the Canadian postal code. It's shared somewhere online as well. And I want to specifically highlight the information of school ID in the second and the third data set, which is a unique ID assigned to each school in Ontario. However, this information is not included in the first data set. So we need to find a way to identify the school ID for each school in the first data set. We'll get into that later. So to start with, the first thing we can do with DSS is to create a new project and then start to play with it and import the first data set. So I'm going to get into the DSS for now. And so I already installed DSS. You can see I have already played with a bunch of different data sets. So what I'm going to do here is just create a new data set, a new project, and I'm going to give a name like LOI fun. and then you can create a data set, and then the next step is import your first data set. So there are a bunch of different choices, as I mentioned, and we're going to upload our files from here. So drop your file by clicking here, and then let me check. It goes to, so this is the data set I have, and I have downloaded already. So we got the PDF of the data. So we kind of get stuck here because the data is in PDF format. It cannot be loaded in DSS, unfortunately. So actually, the first step of this demo is to convert the data in PDF to something analyzable. So let's check the PDF form file. So in the file, you introduce what is this index, and a lot of information about the background of the index. And then on the page 7, if I remember correctly, you'll get into a table of all kinds of school with a score and rank for 3 different years. So this is what we want. And so there are tools that are available can help you turn PDF to a table or like Excel format, because this is a typical issue we face when we're dealing with data, because a lot of the data are published in a PDF format, which is typical, and you need to expect that. So after trying a few different tools for these purposes, I decided to use the Adobe Acrobat program, which can handle this pretty well. So let's open the file in Adobe. So you can see I already removed those pages which are not really relevant to this data set. So in Adobe Acrobat, you can directly save the file as a different format and choose spreadsheet and choose Microsoft Excel workbook. Then it asks you to give a name. Oops, what I didn't do. Ask to give a name. You just choose to save, and the data is being processed. It's taking a while. Okay, it's already here. So let's take a look. So it seems the Adobe is doing a really great job converting the data from PDF to the Excel format. However, you will notice that because on different pages of the PDF, the column names appear every time. So you have rows which are redundant or not useful in this data set. You can choose to remove them manually in Excel, or you can choose to do it in different way in DSS. So for now, I'm going to just close this and choose to do the cleaning in DSS, so that because the process can be reproduced next time we want to do this. However, in this case, we might not need to do that. Just for demonstration purpose, I'm going to do DSS. So coming back to the DSS, you can see the new data set is already in the Excel format. I will just choose to upload the data set to DSS. So you will try to interpret the data and then process it. It's slower than usual, maybe because I'm recording. So it's already done, and then you can preview the data, which will show the first few rows of the data set. So on the top of the table, it already gives you the column names. There's some weird column which doesn't have a name, like column 2, column 4, and we need to check it later. But at this point, it looks pretty clean, and we'll just choose to create the data, and it will bring this data into this format. And at this point, I want to highlight a functionality in DSS, which is in it, under each column, there are an indicator, which is a line that indicate three different kinds of cells in each column. So the green line means the green color means they're good information or good values under that column, and the red one means there's some invalid information under that column, and the gray color means there's some missing values under that column. So basically, it gives you an indicator of the health of each column so that you can dig into the columns and to decide what you're going to do with them. So first of all, we see the school ID. There's some red ones, so we're going to filter use based on validity. So we want to see who are those invalid rows by just clicking here. So what you see is actually those rows I just mentioned. They're all about the names of the columns. So we can start to process data for now by create a preparation script and create a new script, and then to start the data processing. So for this first issue, it's really simple. You just choose to remove those rows. And I want to highlight that because as you could see, after removing this row are gone, and there's a thing here on the left side panel, which records what we had done on this data set, and also gives you information about how many rows are modified. And actually, when I look at the rows I modify, it's 613, and I realized it's a mistake I made because I don't want to remove all the rows, but I just want to remove the invalid rows. So I made a mistake. And what's nice about DSS, you can actually delete the step and all the things will come back. So I will choose to click on the column, and then actually what I want to do is remove invalid rows, but not all the rows. So that's what I want to do. So but for this accident, you can actually see what you can do when you make a mistake in DSS. So the whole process is, you can feel a bit safer without destroying the whole project when you make a mistake, because this process is really reproducible. And also this little eye here, if you want to view the impact of the step, which is right now, or you can choose to not view it, which is like those rows deleted by you will be gone. And in the meantime, because we filtered this row to only see those invalid ones, right now we want to remove the filter. So the filter is really a handy tool to help you to find out where are the issues with the data set. So you can choose to add filter or remove filter quite easily in this tool. So this is the first issue we had, and so you can see the school ID column become pretty healthy. School name, they're all green, all good. And then we come to the column 2, which is we don't know what's going on. So what we can do is, like we did, is to do a filter to see those empty cells. Where are they? It seems it's not really helpful. So we can choose to do another filter to see those valid rows instead. Okay, so it seems this valid row, our information actually should be under the column of family of schools. So for some weird reason, or during the conversion process, the information got to this column instead of this column. So the next thing we're going to do is to move this information or this data to the right column it should be. And so let's try to, so first of all, remove the filter, come back to the script, which is always the place you do processing. So I'm going to add a script or do a task, And as you see, there are a bunch of things we can do for data cleaning or data wrangling in this tool. For this particular task of moving information from one column to another column, I will do a custom code function, and okay, custom code. Why it's not appearing on the list? Okay, so here is a custom formula. This can get a little bit more complex, but I found this is the only way I could do this in DSS. So the goal is to move the information from column 2 to family of school. So in this specific custom formula, I would choose to use output column to be family of schools. And I want to create a formula or expression, which you can imagine as the same as Excel, to move the information to the family of school. So it can get a bit more complex here, but I'm just going to, for demo purpose, and do that and to show you the effect of this expression. So the specific task is if the column of family of school is empty. So that's when there's a value in column 2, the column family of school will be empty. So if this is empty, we're going to copy that information from column number 2. If it's not empty, then we will just keep the information of family of school. That's pretty straightforward. So this is the if else expression actually in DSS. So however, we saw the formula is invalid, incorrect formula, person arrows. Oh, so, okay. So there is something wrong with this expression. And typically this kind of error could be related to the variable names, for if this variable involves empty spaces, like. So let's try to fix it by adding this and this to it. Let's see what we get. Okay. So since it's not useful because it will treat this as a character or a string value rather than as a column name. So the only thing seems to possible is to first abandon this task and change the column name of family school by stripping its white spaces. That's one of the typical issues you will face when you're doing data wrangling, is for this variable name, they'll come in different shapes or different taste, and you need to tweak them. And as you see here, the new step I just did also get recorded in the script. And then right now I'm ready to do the custom code using the same process I just demoed. I'll just do it really quickly and add an expression, which is if family of school equals empty, and I will copy the column name too. If it's not empty, I'll just keep it. And as long as you type in the expression right now below here, will give you an overview of what will happen for that specific action. And I will just say OK. So right now you see all this column become all green, and you can choose to filter this column by showing the valid ones, and then you can see the information which was here get copied to this column, which is what we need or what we want. So after you got those down, you can choose to unfilter, either by removing all the filter here or by clicking actually the red filter icon here. And then you can remove this column because it's not useful anymore. And actually for other columns behind this, there are also other issues you want to fix. I'm just going to do that really quickly here. So right now, as you see, if after we go through those all this process or the scripts recorded here, we finally get the dataset to a clean format like here, which you can also do in Excel, in other kind of technology you use. But the strength of this DSS is that the script get recorded, and as you can observe from my process using it, I can go back to make edits. Actually, I can also arrange the process or the order of those steps. So sometimes you might want to do that something first because they are dependent on each other, and you can easily arrange them by dragging the scripts on this left panel. So after we are pretty happy with this result, we can save the script as a recipe, and then in the same time we want to build a new data set just by running this, because actually when we're exploring this by building the script, nothing happened to the actual data set. It's an interactive process for you to chat with the data, to understand the data, to debug the data. However, nothing has been actually processed to turn the data to another data set. So the recipe what recipe can do is to actually to process the data and build an actual new data set. So right now you click add and build. DSS will just process the data and turn that into a new data set, and it directly brings you to the flow chart, which is only involved 3 different components right now. So the first one is the raw data set, and then this is the recipe we just created, and then this is a new data set it prepared. So the flowchart can give you an overview of what has been done, and that's pretty neat, I think. So the next thing we're going to do is to add more data set to this new project. We're going to do the same to upload a new file. So the next thing, let me see what we want to do. And we've done this. We have done this. We've done this. Okay, we haven't got a chance to see this, but let's come back and load another data set, which is the contact information, I think, to the project. We can do the same and preview. Because this data set is hosted on an open data catalog, so I'm going to trust, or you can see the data is pretty clean and they are really well organized. So we just choose to create a data set, and then we can review it. They're all green and nice. However, there are some issues with this column, but the reason is it's by default it has been recognized as an integer. However, it should be the string, and we can fix that later. And it's not relevant to the project anyway, so we're going to do it right now. There are postal code here, as you see, and there are, for example, the board type, the board language, which we're interested in because we want to contrast the English and French schools, and there are school number I just mentioned, which is unique for each school. School name, school level, secondary versus elementary. So there's some information we want to extract from this data set. So we can do that later. So next is to come back to the data set and add another data set we're interested in, which is the enrollment. This is also downloaded from the website. It's in Excel format, and let's see how DSS is handling it. It seems also clean, and we can just choose to create a data set and review the data set again. So for each data set, for each school, there's similar information including school ID, school name, school level, school type, school language. And actually we see in the enrollment column, which is what we want to focus on, there's some red values. let's see the invalid rows. Okay, interesting. So they decided to use just the string value as when the school student number get under 10. So we want to clean that, and maybe we can just arbitrarily choose to replace this value with 10, just for demonstration purpose. So to do that, again, we'll create a preparation script, and then we do using under the script here, there is an option of replace, I think, somewhere. So let's first clean those cells. Okay, so for those invalid cells, they become empty. And then, so you can see empty cell right now are empty. They used to be smaller than 10. So the next step is to fill empty rows with the value, which is 10 we want. And that clean the data. For example, for this row, it becomes 10, which is what we want for this demonstration. And then it's the same, it got recorded here. And right now we're happy with it. We save it as a recipe again, and then build the new data set. So you can see from the flowchart here, well, and this is the first things we did for the LOI dataset. This is the enrollment dataset we just did, and there's another dataset we didn't really do some cleaning because this is pretty good already. So the next thing we're going to do is the next challenge is to actually connect those different data sets together. So I'm going to go back to the LOI dataset, not this one, the processed dataset. So it's LOI prepared. And then I wish to connect this dataset with other dataset. And the only way to connect is the school name, because the school ID, they are specific to the school board, I guess, because I tried and didn't work. So what we're going to do is to join those two different datasets by the school name, and let's see how to do that. So we can come back to edit a script that build a dataset, or we can create a new script. Let's see. Let's create a new joined script. And right now, this is a really critical component of data wrangling, and which is about joining different data set. Let's see, we're going to first, like what we did, add a task to the script, and then there's a join. And under the join, there are different kinds of join, including memory join and fuzzy join. They are a little bit different between those two. And for this specific school name column, I want to use fuzzy join because sometimes the school name could be spelled a bit differently. For example, sometimes the public school, they're spelled as PS. So I just want to use fuzzy join for this purpose. So the column to join is school name in this data set, and data set we want to join is called enrollment by school prepared, and then the join column in that data set is school name as well, and the columns to retrieve is school level, school type, and school language. So those information is what we want. So as you can see, as when I was typing this information, the information got copied here already. However, for some reason they are empty. A lot of them are empty. Let's check for the valid rows. We get some of the information. And however, this is a really small portion of the data set. So there should be something wrong going on with this. You want to dig into that. However, I think we might not have time for that. So I'm going to just try another join with a different data set. And let's join, rather than joining with the enrollment data set, let's join with the contact information data set using school name. Dataset to join is the public funded school contact, and the column there is school name as well, and we want to grab the school number, which is what we want, and also the postal code, I think, and other things: school level, school language, school type. So when we go through this, you can see the data actually get already processed and brought into this data set. And for some reason, I think I need to dig into that, or you need to dig into that. This join did much better than the other one. So there's a lot of try and error in the process of doing this. And we want to know the reason, but maybe in the demo we don't have time for that. So after doing this, we want to remove the first trial we did because this is not useful. And then right now, after joining this LOI dataset with a contact information dataset, we retrieve the critical information of school number. And we want to do another join. Right now, this time we use memory-based join using the school number to join with the enrollment data. And we want to get the enrollment number. And, oh, sorry, this should be school number to retrieve the enrollment number. So right now, then you can see the enrollment number get all joined into the new data set through the newly added school number, which should be a bit more reliable because they're unique and shared compared to school names, which can be spelled differently. So right now, we got almost all the information here except the postal code, which I think I will not demo here. Then we're ready to explore some of the relationship between them. So just for demonstration purpose, you can visually explore. First of all, let me save as a recipe and build a new data set. And let's name it as final and build it. So you can see this flow has been updated to represent the process we have gone through. And then right now we want to use the final data set and to explore it and to answer some of the basic questions. And first of all, let's see whether we can create a new script, analysis. So first of all, explore the column here, do some analysis to see the distribution of the value in that column. And this is just one way to explore it. For example, rank, you can do the same by choosing to analyze it. They are really simple, just for validity check sometimes, or to get a sense of, in case there's a missing value, for example, you can quickly identify the missing value or outlier in that column. And actually, because the research question was about finding out the change over years, actually we need to create a new variable based on, for example, we want to use the 2014 score and compare that to the 2009 score. So what we can do here is to, let me see, what's the way to do it? Okay, do the custom code again, I assume, and then create a new column called score change. And then it's simpler than the one we tried. So it's LOI for team score minus LOI 9 score, and you can see this is a sample output and it seems correct. We're going to save it, and then there's a new column created somewhere here, and we want to do the same for the rank change, and it's LOI 14 rank minus 9 rank. So this is the sample output. So here we get two new variables we created for analysis, and as I show, you can do a quick overview or analysis of the distribution, and you can find out, oh, there is some school which improved quite significantly because the number becomes smaller. That means there are less challenges faced by students in a school. And there are some other school who kind of get didn't improve or become actually worse to support students. And this is really simple way to just see the distribution of the value. And additionally, there are charts you can produce, and this can be used for exploration purpose as well. And for example, we want to see there are different types of chart. We want to see a group bar chart, and we want to see that based on school type. Let me see, school type as an x-axis. For the y-axis, we want to see the score change. You can just quickly drag and drop them and to see the difference. Actually, a lot of them are no value, and so we might want to try a different one to try the school language. Oh, they're all English. Oh, I realized because Toronto School District, they don't have any French schools, so this is also not useful. Let's try school level. So compare the secondary and the elementary school. And actually, for those schools, didn't provide information about the secondary, the school level. It's much higher, and we can filter that information because those are distorting the comparison between the secondary and elementary. So we can drag the school level variable into the filter here, and then choose to hide those without value. So actually, you can see those are pretty similar, the change, and I mean, this just to show you what's possible and what can be done with this kind of visualization or chart producer tool in this technology. And you can also add, see what we can add. Let's remove this and add a word as an access. And you can see for which word they improved and for which they kind of didn't improve. And we can add just a different visualization to add the level as color. So for each word, we want to see the change for both elementary and secondary school. As you can see here, for this specific word, oh, this is not one specific because the word they're treated as a numerical variable. So it's getting, I mean, this is not right. I can go back to change the type of the column by clicking here and change data cleaning. So this step should be completed before in the data cleaning step. So I'm going to first save this recipe and go back to the recipe I produced earlier to clean this LOI dataset. So I missed the one step is to change the type of the word to a text. So it's not actually, it's not it should be saved as a string. It's not an integer value, so it becomes categorical. So we're going to save this recipe and update the schema and run this recipe, produce a new data set. So it kind of also, although I made a mistake, it kind of demo you how you can go back to the earlier recipe to change something and reproduce a newer data set. And then right now we can come back to the final data set and or to come back to the recipe. So this one. Oops. Let's view it in a flow. So this is another recipe we need to run to produce the results. And go back to the flow. This is another recipe. I mean, there should be a way to do this better. I think I didn't get this right, maybe. Let's see whether this has been updated. Oh, there's still decimal. Interesting. And okay, edit the recipe which produced this data set. I'm going to do that right here and see whether it's better. So it's saved as a stream. Okay, save it and update it. And let's go back to the flow and check the new data set. It's still decimal. I don't know why it happens. But anyway, oh, new data set. But I was just trying to demo putting this in axis, in the x-axis, score change to y, and adding another variable school level into it, so you can see the difference, the change, and also adding a filter to the visualization and filter some value you don't like. So this is, you can, I mean, if we can fix the level of measurement for Word, it might be a different visualization, but this is just to demo you how it could be done to explore the data set. And also you can actually, I think you can sort them, sort the bin if the word are, the column is in a categorical level of measurement. And also there are other things you can do is to, for example, produce a scatter plot based on the x-axis. We want to use the enrollment, and we want to put it here. So for the circle by, we want to choose the circle by school name, and actually you can see this is to see that maybe the correlation between school size and the change of the opportunity score. So this is another way to see like two numerical variable and their information. You can, like what I did, add some information about, for example, differentiate them based on their school level. It doesn't work. Apparently I'm doing something wrong. But to adding something to the different things in this visualization, you can get additional information or better understanding of the data set, and hopefully you can answer some question you want to ask. So I think that brings to the end of this demo, and there are a lot of things you can further explore. For example, we didn't actually try to turn the postal code and merge the information from the other data set about the geo point of schools what I was planning to do is to have that information and turn that into visualization, a visualization of the geographical distribution of those change of the score, of the LOI score. So you're free to explore that, and maybe you can bring some example to the class next time and share with the class somewhere in Knowledge Forum or on Twitter. And just to review what we did, we just mainly focused on cleaning the data, and we spent some time looking at the data in different ways, both using the functionality of filtering or using the visualization techniques embedded in DSS. And we didn't get into too deeply about shaping the data and augmenting the data, and that's something you can explore in the future, because they're also pretty critical, because for shaping, sometimes the data is in a wide format and it's not analyzable, and you turn it into a long format. That's one of the typical challenge. And if you can search online, you can find some maybe other demo to do that, and in different tools to do that. And so you're free to explore. And there's some open data set available on a variety of different places you can choose and to explore. And so enjoying hacking and happy data wrangling.